Here we have our second example. We're just going to go through piece by piece like we did before. We want f of negative 5 to equal 1. That's just a point. Negative 5, comma, 1. F of x equals y. So negative 5 is my x, 1 is my y. So at negative 5, 1. There's my first point. My next piece says the limit as x approaches negative 3 from the negative side, so I have a left-hand limit, has to equal negative infinity. So I'm going to approach negative 3 from the left side, and my y value is going down to negative infinity. Remember, the limit is the y value. So I must have a vertical asymptote here in order for the limit to be going to either of the infinities. You have a vertical asymptote, so I'm going to put those dotted lines in. It just helps me to show that, hey, I'm not crossing that line. So I put a down arrow and put some dotted lines for a vertical asymptote. As x approaches negative 3 from the positive side, that's a right-hand limit, the limit is also negative infinity. So from the right side of 3, I also have a down arrow. The y value is going down to negative infinity. Okay, and my next piece, f of 2 is undefined. I have to draw a hole or a vertical asymptote. How I know that is it's undefined. Two options. Is it a hole or a vertical asymptote? And remember what we said before. If the limit is a number, I'm going to draw a hole. If the limit is d and e for either of the infinities, I'm going to draw a vertical asymptote. They're both undefined. They just have different limits to tell you which one to draw. Okay, so we're undefined at f of 2, and the limit as x approaches 2 is 4. So at 2, do I have a hole or a vertical asymptote if the limit is 4? It must be a hole. So I'm not going to draw a vertical asymptote there. So as x approaches 2, from both sides I should approach 4. I'm going to put an open circle there. I'm going to do just tiny little lines off it to remind myself to connect it, or else I can't find the limit if there's nothing to hop onto. So my last piece is as x goes to infinity, f of x is 5. So again, we kind of previewed this. If x is going to infinity, that is not up or down. Remember, x is either left or right. Y is the up or down. So if x is going to infinity, is that x going to the left or to the right if it's going to positive infinity? That is x going to the right. So as we go far out to the right, I don't want it to look like I'm going up or down. I want it to look like I'm stopping at 5. This is called a horizontal asymptote. So as I go out to the right, I want to show that I'm stopping at 5. So I'm going to do those dotted lines again to show that I'm stopping. And I'm just going to do a little arrow. So something that wouldn't follow this, like if we look back at this example, if we took the limit as x goes to negative infinity, as we go far out to the left, it looks like we would just keep going up as we go out. We'd keep going out and go up. So that would be infinity. So we just want to show that it's stopping, kind of like this one. This limit as x goes to positive infinity, I would say it looks like it's stopping at 0 for that x going to infinity. So if it was a straight arrow up, that would mean it's going up to positive infinity. Or if you make it look kind of like it's stopping, then you've shown that x is going to infinity, y is stopping at a certain number. So this one would be 0, whereas x going to negative infinity, it looks like it's going up. As we go out, it's going to go up. So as we go to the right, we want to make sure it looks like we're stopping at 5. There's a couple on the homework where it kind of throws these at you. So x is going to infinity means the right, and remember for the homework, as x is going to negative infinity, that would mean what direction? It would mean left. So up and down is when y is going to positive or negative infinity. If it's x, we're talking about left or right. Negative infinity is left, positive infinity is the right. Okay, so we have that on here. As x goes to infinity, we're going to stop at 5 in the y value. Our last step is the hard one. We're going to connect these, and we just want to keep in mind there are tons of different answers, and so even though it feels weird, just kind of guess how they connect. It's probably right as long as you haven't, like colored through a hole or something or violated one of these things we wanted to make true. So let's start on the left side here. I have the point -5, 1 that I want to cross through, and I have this left-hand limit going down to negative infinity. So I'm just going to connect these two pieces. I'm just going to do a nice smooth curve. And then I could, switch and make this an upside-down parabola. That would be cool. That's one way. Or I can just kind of say, hey, I'm just going to keep going up. There's no one way to do this. There's a ton of different ways. And then I have 3 things to connect on the right side. I have this down arrow that I'm going to connect to this hole up here. Just trying to do smooth, nice curves. And then I'm going to connect it out. As x goes to positive infinity, y is going to look like it's stopping at 5. So again, lots of answers. No one correct answer. I don't even have my notes out, but I've written this before and I probably don't have the same picture. So let's just double check we did it right. There's lots of right answers. Let's make sure this is one of them by making sure these are true. Did we go through the point -5, 1? Yes, we did. We get a point for that. And then as x goes to -3 from the left side, are we going down to negative infinity? -3 from the left side is going down, so I'd get points for that. As we approach -3 from the right side, are we also going to negative infinity? Yes, we are. Is f of 2 still undefined? Yes, there's no y value above or below 2, so that is still undefined. As we approach 2 from both sides, do we get to 4? Well, let's check. Going in from both sides, they do meet at 4, whether I hop on from the left or the right. They're both going to 4, so I get points for that. And lastly, as x goes to infinity, so x is left or right. Positive infinity means to right. As we follow to the right, does it look like we're kind of bottoming out at the y value 5? Yeah, I think we did that as best we could. That dotted line kind of helped show that we're stopping and doesn't look like a straight up arrow going to infinity. It looks like, hey, I'm approaching 5. Similar to how we kind of accidentally made this one look like it's stopping at 0. It wasn't intentional for this one because it didn't have to be, but as long as you show it's kind of getting flat, then that's going to be the limit you approach as x goes to positive or negative infinity. So there's the much harder direction, and that just helps us get better at reading limits from a graph to show you the other way. Here's the limit, draw the graph. But as long as at this point you can read a graph and get the limit, then you're good to go. If you think you are still struggling with it, try the WebAssign, and definitely just reach out for help, and we can do some more one-on-one to get you reading these graphs at the very least before you start drawing them on your own.